One more example on calculating the percentage of others. They are saying sodium carbonate reacts with the calcium carbonate to form, sodium carbonate reacts with calcium chloride to form calcium carbonate and sodium carbonate. In an experiment, 53 grams of sodium carbonate and 44 grams of calcium chloride were mixed, forming 23.6 grams of calcium carbonate. What is the limiting reactant? That is Roman number 1. Roman 2 says, calculate the percentage yield of calcium carbonate. Now let's begin by answering the Roman 1. Roman 1 says limiting reactant. I told you, this is how we calculate the limiting reactant. We get the number of moles of each reactant. The reactant that has the least number of moles, that is the limiting reactant. So let's begin with number of moles of sodium carbonate. We know that sodium carbonate, the RFM, this is 23 times 2 plus 12 plus 16 times 6. So this is 46 plus 12 plus 48, this is 60. So this is 160 grams. So the number of moles, this is molar mass, not number of moles. This is the relative formula mass. The number of moles N is equal to the mass. They say 53 grams of sodium carbonate. So this will be 53 divided by 100, 0.6. Let's calculate and see what we get. My calculator. This is 53 divided by 106. We get 0.5 moles of sodium carbonate. Now, after knowing the number of moles of sodium carbonate, the next thing we are going to do is looking at the number of moles of calcium chloride, moles of calcium chloride. We know that calcium is 40 plus 35.5, which is chlorine, times 2. This is 40 plus 71, which is 111 grams. So our number of moles here in the question, they talked of 44.4 divided by 101. So 44.4 divided by 101, this gives me 0.4 moles. So I conclude that the limiting reactant is calcium chloride. That is the limiting reactant. Calcium chloride is the limiting reactant. We have answered part 1. Now, let's look at part 2. Part 2, they said calculate the percentage yield of calcium carbonate. Calculate the percentage yield of calcium carbonate. Now, we said, having known the limiting reactant, we're supposed to write an equation. So our equation is sodium carbonate reacting with the calcium chloride, and they said it forms what does it form? It forms calcium carbonate. It forms calcium carbonate plus sodium chloride, which is also a solid. Now, they need the percentage yield of calcium carbonate, which is here. Now we have known that this is the limiting reactant, and we are going to use the stoichiometric values of calcium carbonate to calculate the amount of calcium carbonate that is produced. We are using calcium chloride rather to determine the amount of calcium carbonate that is produced. So from this equation, we realize that the RFM, we realize that 1 mole, let's use moles, 1 mole of calcium chloride produces 1 mole of calcium carbonate. But how many moles of calcium chloride did we have? We had 0.4. Therefore, 0.4 moles of calcium chloride will also produce 0.4 moles of calcium carbonate. Now, we want the mass of calcium carbonate. Mass of calcium carbonate is equal to number of moles, which is 0.4 times the relative formula mass of calcium carbonate. And let's get it. Calcium carbonate, calcium is 40, carbon 12 plus 60 times 3, that is 48. 48 plus 6, that is 60. This is 100. So our mass here is going to be 0.4 times 100 grams. This gives me 40 grams as my theoretical yield. 40 grams is what I've calculated all the theoretical, but the actual yield in the question, they say it is 23.6. So again, percentage yield in our same formula is equal to actual yield over theoretical yield multiplied by 100. Therefore, this is 23.6 divided by 40 times 100%, and this one gives me 59%. So the percentage yield of that is 59%. Let me confirm my calculation. It is true. It's 59%. So please, if you're faced with a problem where you need to calculate the percentage yield, endeavor to follow those steps. Thank you.